Here on problem 9 from the practice exam. We're asked to find a power series that is centered at 1 for the natural log of x function. So we need to remember the formula for the Taylor expansion for a function. This is it right here, centered at 1. So what we need to do is find a formula for the nth derivative of x. So to do that, we'll write out the function and several of its derivatives. So ln x, first derivative, 1 over x. Second derivative, it's going to be negative 1 over x squared. Third derivative, get positive 2 over x to the third. We'll go to the fourth derivative, and we'll get negative 6 over x to the fourth. And what we'll start to notice here is that it seems that these numbers in the numerator here, well, first of all, they're alternating positive and negative. And if I were to continue this, I would get 6 times 4, that's 24. It's looking like 6 is 3 factorial, and there's a fourth derivative. If I do a fifth derivative, I would get 24, which is 4 factorial, and so on. So it seems that this number in the numerator is the factorial that is 1 less than the derivative that we're taking. So if we were to surmise a formula here for the nth derivative, put a sort of dot 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 here to say we'll continue this, it would be, we have the alternating positive and negative terms, so we're going to have a minus 1 to the n, and then again look at the first derivative, it's positive, second derivative is negative. Nth power is going to make the first derivative, let's see, if I have a 1 in there, it'll be negative, right? But that's positive, so I need to make this n plus 1 so that I can account for the first term being positive, second one being negative. First derivative positive, second negative. And then what else do I need? I need to have, what do we say? That's going to be n minus 1 factorial in the numerator. N minus 1 factorial. And then in the denominator, x to the power of n. Okay, so that's our term for the nth derivative. Then what I really need for the formula here is I need, oops, I think this formula should be fn of 1 there, not fn of x. Sorry about that, I gotta fix that. So what I need here is the formula for the nth derivative at the center, which this thing is centered at 1. So we'll continue over here. What I really need out of this is the nth derivative at 1, because that's what's in the formula there. So the nth derivative at 1 would just be what I get when I plug in 1 for x there. So that's just 1 to the n, it's just 1. So I'm going to get minus 1 to the n plus 1, n minus 1 factorial. So when I plug that into the formula here to find power series for ln x, I'll just insert that in for the numerator there. So I'll get, and in fact I have to make sure this is at 1, not at 0. So I make that 1, insert that in for the numerator there. I'm going to get minus 1 to the n plus 1, n minus 1 factorial over n factorial multiplied by x minus 1 to the n. N minus 1 factorial, this, I can write that denominator as n times n minus 1 factorial. So if I do that, n times n minus 1 factorial, that n minus 1 factorial cancels with that one. And so basically all I have left in the denominator is just an n. So my series is going to look like this. Minus 1 to the n plus 1. That canceled entirely, so I'm just left with n in the denominator, and then I still have my x minus 1 to the n power. By the way, I'm starting this at 1 because it doesn't make sense to have it at 0, right? You'll see you're dividing by 0 there. And I think on my answer sheet on the practice exam, I made a mistake there. That should be starting at 1, not at 0. Okay, so it also asks us to find the interval of convergence for this thing. The way we can do that is with the ratio test. And so if you do the ratio test on this, I don't really have too much room left here, but if I did the ratio test, this would be what I would get. I get the limit as n approaches infinity of absolute value. I'm just going to get rid of the -1 right away, but it would be x minus 1 to the n plus 1 over n plus 1 multiplied by n over x minus 1 to the n. And then you can see that just like before, we have n plus 1 power here, n power here. That basically cancels all of that. And so all I have left is the x minus 1. So I've got x minus 1 times that limit of what's left, n over n plus 1. And that limit is 1, so that's what I'm left with is x minus 1 absolute value. And again, we know that that must be less than 1 for convergence. So what we get by simplifying this is we get 0 less than x less than 2. This is x minus 1 between minus 1 and 1. You add 1 to everything, you get that. And then, since I'm pretty much out of room here, checking both endpoints, if I plug in 0 to the series here, I'm going to have minus 1 to the power of n. Well, let's just do this. For x equals 0, let's see if we can see this. What happens? I get this minus 1 to the n plus 1 times minus 1 to the n over n. Now, if you multiply these out, what you're going to get, minus 1 to the n plus 1 times minus 1 to the n, look what that is. That's 2n, right? Minus 1 to the 2n plus 1. I'm just going to have to describe the last part because I'm out of room here, but this is going to be minus 1 to the 2n plus 1. Well, this is the same as having minus 1 squared, which is just 1. And then I'll have the minus 1 in front of this thing. So what this actually ends up being, if you simplify it, is this, 1 over n. We know that diverges. So it's going to diverge at 0. Then if you notice, if you plug in the other endpoint, 2, look what happens. When I plug in 2 there, I get 2 minus 1 is 1, so I just get 1 to the n. That leaves us with an alternating series here. In fact, it's the alternating harmonic series, which means that it will converge at x equals 2. So I can do that. Okay. So be sure that you understand what's going on at these endpoints here. So our interval of convergence is 0 to 2, excluding 0, including 2. And that kind of matches what you have for the natural log function in the first place, because ln x is not even defined at x equals 0, so it makes sense that it wouldn't be converging there. ln x is defined at 2, so it will converge there.